Welcome to Part 2 of Fastlane's Certificate and Security Best Practices presentation. What is this presentation about? This presentation provides background information for the dCloud Lab, Collaboration Specialist Training Version 2, Security Version 1. The Collaboration Specialist Training Version 2, Security Version 1 dCloud Lab presents two scenarios. Scenario 1. Deploy unified CM enterprise-level encryption for internal collaboration devices and clients. And Scenario 2. Enable end-to-end MRA encryption for clients outside the enterprise perimeter. The Certificate and Security Best Practices presentation is broken up into 5 lessons that have been individually recorded for your convenience. This is the second lesson, the Public Key Infrastructure, PKI, and Cisco Collaboration. Cisco Collaboration uses a public key infrastructure to distribute public keys. This lesson describes the public key infrastructure and its use in Cisco Collaboration. This lesson builds on material presented in the previous lesson, Cryptographic Essentials for Cisco Collaboration. What is the public key infrastructure and why do we need it? Remember, we want to use shared symmetric keys to encrypt bulk data transmission in individual sessions, for example, for TLS or SRTP sessions. Key generation and encryption-decryption are fast for symmetric encryption algorithms, but keys are short-lived and must be changed frequently. We want to use asymmetric keys to encrypt and exchange these shared symmetric keys. Asymmetric keys are long-lived, so if we can use these keys to exchange the symmetric keys we need for individual sessions, then we can simplify the key management process. When using asymmetric keys to exchange shared symmetric keys, the shared symmetric key will be generated by one party, encrypted using the other party's public key, and then sent to that other party. Remember, anyone can use your public key to send something to you secretly. That other party will decrypt the shared key using their private key. Remember, only your private key can be used to decrypt a message encrypted using your public key, so you better keep your private key secret. Public keys are exchanged using certificates. We talked about certificates in the previous lesson. Cryptographic Essentials for Cisco Collaboration. What else are asymmetric keys, public-private key pairs, good for? Asymmetric keys, public-private key pairs, are also used for digital signatures. Digital signatures are used to authenticate messages. In fact, we use asymmetric keys for all of our cryptographic services. Authentication. Your certificate authenticates you. This is a vital service at the collaboration edge. Confidentiality. Only you can decrypt messages encrypted with your public key. Integrity. Messages with digital signatures can't be changed. And non-repudiation. You can't deny you sent a message signed with your public key. For all of this to work, we need the public keys of the parties with whom we communicate. This is the foundation upon which our cryptographic services are supported. But we still need a way to exchange public keys. If I want to send a message to you, how do I get your public key? Also remember, we use certificates to exchange public keys. Remember our 2 issues with certificates. Who signs them? Self-signed certificates are bad. If we can't sign certificates ourselves, then who signs them? Someone else has to sign them. If someone else signs our certificates, then everyone needs the certificate of that party. How do people get that certificate? We need a way to securely distribute the certificate of the signer of everyone else's certificates. We need the public key of the signer of a certificate to validate that certificate, but we get that public key in a different certificate signed by someone else. See the problem? The public key infrastructure, or PKI, is designed to address these two issues. We have to trust someone to get this started. There's no way around it. If we trust one party to sign everyone else's certificates, then we only need to have the certificate of that party. The PKI uses trusted introducers to distribute public keys. The trusted introducer is called a certificate authority, or CA. The CA is the party we need to trust to get this started. The CA signs everyone's certificates using its private key. Everyone needs to know the public key of the CA. In fact, there will be more than one CA, so we need the certificates for the public keys of all the CAs that have been used to sign their certificates of all of the parties with whom we want to communicate. These are our Getting Started certificates. So, with the PKI, instead of having to get everyone's certificates validated to get started, all we need are valid CA certificates. In PKI, everyone has a public-private key pair. The CA has a public and private key. Everyone else has their own public and private key pairs. So everyone has a public-private key pair. Everyone but clients. Clients don't need certificates, but all the servers they talk to do. Everyone's public keys are documented in certificates signed by the private key of the CA. What does that imply about the CA's certificate? The CA's public key is self-signed. We know what that means. The CA certificate can't be easily validated. Everyone needs the public key of the CA to use to validate everyone else's certificates. Everyone, including clients. But the certificate containing the public key of the CA is self-signed, so you can't be sure the certificate is valid from its signature. You need to get that certificate and be sure that it's not been tampered with. There are various ways to distribute the public key of the certificate authority. The CA certificate can be built into your web browser or other software. You can go and get the certificate in a variety of ways. Just be careful. In Cisco Collaboration, phones have Cisco manufacturing CA certificates, among others, built into their firmware. We also use ITLs and CTLs to distribute initial trusted certificates. The Trusted Verification Service, or TVS, is also used to help verify certificates when the CA certificates are not available. For Cisco applications like CUCM, CUC, IM&P, Expressway, and so on, we need to add the CA certificates needed to validate the certificates of the party with whom they communicate. The dCloud Lab explores how to do this. Once we safely have the CA certificate, it's easy to exchange public keys in certificates signed using the CA's private key. Ask for the CA signed certificate from the party to whom you need to send encrypted data. Validate that certificate using the public key of the CA, which we already have available, built into our browser or collaboration endpoint, or added to our collaboration application, or downloaded to an endpoint using a CTL or ITL. This happens every time we set up a TLS or SRTP session. We'll talk about this in a later lesson. All we need now is a way to get public keys signed by a CA. We need a certificate for our public key. How do we get the certificate? Parties participating in the PKI generate a public-private key pair. The private key is kept secret in local storage and is never transmitted anywhere. We don't ever have certificates for private keys. A certificate signing request, or CSR, containing the public key is created as part of this process. The CSR contains other information besides the public key, such as the subject of the certificate, which is normally the fully qualified domain name of the thing being secured, such as a phone or a web server. CSRs for Cisco Collaboration applications specify the key type, the key length, and the hash algorithm. In Cisco Collaboration, as of CSR Release 10.5, we can use multi-server certificates to specify the names of other servers in a cluster. We submit the CSR to the CA for signing to get a certificate for our public key. We do this in the dCloud lab. After we submit the CSR to the CA creates a certificate using the information in the CSR and signs the certificate using its private key. Anyone with the CA's public key can validate the certificate. Anyone who needs to use our certificate needs the corresponding CA certificate. The signed certificates are returned to the requesting party. In the dCloud lab, we will use a Microsoft Enterprise CA to sign certificates for our Cisco Collaboration applications. Where can I find a CA to sign my certificates? Many vendors offer CA servers as a managed service or as an end-user product. GoDaddy, VeriSign, and Entrust Technologies offer certificate signing services, and their CA certificates are included in current browsers. There are now many such enterprises offering these services. That doesn't necessarily make our life easier. Microsoft Windows Certificate Services is a Windows Server add-on that allows an organization to set up its own enterprise CA. This service is easy to use, and many deployments do so. We use one of these in the dCloud lab. The CA proxy function, CAPF, in Cisco Unified Communications Manager can act as a standalone CA for endpoints. We need to turn this service on if we want to enable secure encrypted communications for our deployment. Have you heard the term CAPF enrolled? Use a public CA like GoDaddy or VeriSign for certificates exchanged on the Internet. Use an enterprise CA for certificates exchanged within your enterprise. When requesting a public CA certificate, there are a number of options and different types of certificates. Here's a table from the CST2 security presentation showing what's supported or not. Single host domain certificates are supported everywhere. Multi-server certificates are supported for some Cisco Collaboration applications. We'll discuss this in the next lesson. Wildcard certificates are not supported on any UC applications. Here's GoDaddy's description of the different public CA certificate options. We're not recommending GoDaddy one way or another. We're just using them as an illustration. Information describing options for public certificates is readily available on the Internet, and it's not difficult to figure out. Note that these are yearly costs and that the multi-server certificates are more expensive, but will certify 5 servers. For example, the publisher, 2 subscribers, and 2 IM&P servers in a 5-server cluster. Here's GoDaddy's description of the different types of public CA certificates. The different types of certificates reflect the effort the CA spends validating the organization. Domain validation may be a simple check using DNS, while more is done for organizational validation, and still more for extended validation. More validation means more expensive. The amount of validation that is done is reflected in the web browsers of clients connecting to your server. We get either a padlock or a green address bar, depending on the validation. You will see a green address bar for extended validation certificates, in addition to the green padlock. You will see a green padlock in the address bar for the other types of certificates. When I generate certificates, what should my certificate lifetime be? Things to consider. Reporting on certificate aging is getting better. The default lifetimes of most Cisco Collaboration certificates is 5 years. The ITL Recovery Certificate has a 20-year lifetime. From the 1st of April 2015, all SSL certificates will be issued with a maximum validity period of 39 months. This restriction has been agreed by all parties of the CAB Forum, a collection of certificate authorities and browser vendors, and is therefore industry-wide. This reduced validity period is being imposed to help increase the security of SSL TLS. We saw a recommendation somewhere to use lifetimes longer than 5 years, but we can't find where we saw that recommendation and can't see that it's possible for public certificates. If we can find that information, we'll add it to the presentation. Here's the big picture. In the next lesson, Certificates in a Cisco Collaboration Deployment, we'll answer these questions. In a Cisco Collaboration deployment, who needs their own certificate? Who should sign that certificate? Can we use an enterprise CA, or do we need public CA certificate issued? Who needs what CA certificates? Thank you for taking the time to watch our video. We hope you enjoyed it.